Let's take a look at this question. We want to find the amplitude, the period, the phase shift of the function y equals 3 times sine of the quantity 2x minus pi. We also want to take a look at the graph of this function. So let's make some notes here regarding our formula. Keep in mind this function is in the form of y equals, we have our amplitude times our sine function here, and inside our parentheses we're looking at omega x minus pi. So let me make some notes here. The one that looks like a W is your omega value, which we've been working with in past sections. Phi is a circle with a vertical line through it, spelled PHI. And let's go ahead and take a look at some of these components that we can match up, right? Our A value, or our amplitude in this case, is going to be 3. Our omega value is the number 2. And so we can use that value when we're going to come find the period for this problem. Remember that our formula for period is 2 pi over our omega value. So for the period, we have 2 pi. Our omega value here is 2. Right? And we can reduce this fraction. So the period for this problem is going to be pi. And when we come down to do our phase shift, our formula for phase shift is going to be our phi value on top, omega on the bottom. So let's go ahead and make some notations here based off the problem we have. Phi in this problem is pi. And remember that we had our omega value as 2. So when we're talking about phase shift, let's go ahead and plug these numbers in. Our phase shift is going to be pi over 2. Phase shift, when you're looking at these problems, is you're going to be moving these graphs either to the left or to the right based on some values that are given to you here in the problem. If your phi value is something positive, so something greater than 0, in this case your graph is going to be shifting to the right. If your phi value is something that is negative, then your graph is going to be shifting to the left. So keep in mind, off our problem, our phi value here was pi, which is something that is positive. So we're going to be moving to the right. Pi over 2 units when we go to graph this function. So let's go ahead and take a look at our graph. We're going to start with just the basic sine of x graph. And let's go ahead and take a look at one of the points on this graph, just so we have it to use as a reference point when we draw the rest of the functions here. Let's go ahead and look at the point pi over 2, comma 1. Right, which is the point you see labeled there on your graph. And then let's go ahead and start performing some of the transformations. Remember that our amplitude was 3, so let's go ahead and take this function and multiply all the y values by a factor of 3. When we do that, you're going to see the graph that you see there in blue, that is 3 times sine of x. Alright, and take a look at what happened to that point. Pi over 2, comma 1, we multiply that y value by 3, and so that new point now appears up there at pi over 2, comma 3, and it's a point on our blue graph. Okay. Now let's go ahead and take a look at what happens when we're working with that omega value of 2. Remember that that's producing a horizontal compression on our graph. So instead of only seeing one cycle of that sine graph between 0 and 2 pi, we're going to see 2 cycles instead. So I'm going to go ahead and take the blue portion off, and let's go ahead and graph y equals 3 times sine of 2x. Alright, so that you'll see we have those 2 cycles. One cycle the graph goes from 0 to pi, and then the second cycle goes from pi to 2 pi. And if we take a look at that point, the one we started with, pi over 2 comma 1, we had multiplied it by a y value of 3 initially. And now take a look at our new point here. Right, this one is the point pi over 4 comma 3. So remember that when you were performing that horizontal compression, you were taking your x value and multiplying it by 1/2. Right, that omega value was a 2, so when we go to multiply it, we're multiplying by the reciprocal 1/2. So if I take pi over 2, multiply it by 1/2, that's what gave me that pi over 4. And for our last transformation here, we're going to take our graph and we're going to be shifting it to the right pi over 2 units. So let's take a look at what happens with our graph here. I'm going to go ahead and just leave the green one where it is, and I'll turn on my last graph. Right. And let's take a look at that point pi over 4 comma 3. If we shift it over to the right pi over 2 units, our new point is going to be at 3 pi over 4 comma 3. So let me go ahead and take our green graph off. And there you can see the purple graph, which is our final function relative to the sine function that we started with.